Tech in 5.
Python in practice, master real-world projects in 5 minutes. Hyperparameter tuning, the key to optimizing and enhancing the performance of your machine learning models. Welcome to Tech in 5. In this episode, we'll explore what hyperparameters are, introduce you to powerful tuning techniques, and show you how to apply these methods using scikit-learn to achieve the best model performance. Hyperparameters are important settings that need to be configured before training a machine learning model. Unlike model parameters, which are learned during training, hyperparameters are set by the data scientist and have a significant impact on the behavior and performance of the model. Hyperparameters are crucial settings that need to be configured before training a machine learning model. Unlike model parameters, which are learned during training, hyperparameters are set by the data scientist and have a significant impact on the behavior and performance of the model. For instance, consider the learning rate in many algorithms, which determines how quickly a model adapts to the problem. A too high learning rate can cause the model to converge too quickly to a suboptimal solution, while a too low rate might make the training process too slow. Another example is the number of trees in a random forest model. More trees generally increase the model's accuracy and stability, but also raise the computational cost. Lastly, the kernel type in support vector machines affects how the data is transformed to find the optimal boundary between the classes. Each kernel type, linear, polynomial, or radial basis function, can drastically change the model's effectiveness depending on the data. Understanding and choosing the right hyperparameters is thus essential for building effective and efficient machine learning models. As we dive deeper into hyperparameter tuning, let's explore one of the most powerful tools available in scikit-learn, GridSearchCV. This method allows us to systematically search through multiple combinations of hyperparameter values, finding the best mix that maximizes our model's performance. Let's see GridSearchCV in action. We'll use a support vector machine as our classifier and tune its parameters. GridSearchCV works by defining a grid of hyperparameter settings to try. It then systematically trains and evaluates the model using each combination through cross-validation, ensuring each set is rigorously tested. In this example, we defined several values for C, kernel, and gamma to test different configurations of our support vector machine. GridSearchCV evaluated each combination using 5-fold cross-validation and found the combination that resulted in the highest accuracy. This method is extremely thorough, ensuring that the hyperparameters chosen are well suited to our data and model type, leading to the most reliable and robust performance. As an alternative to GridSearchCV, let's explore RandomizedSearchCV, another powerful tool from scikit-learn designed to optimize hyperparameters. Unlike GridSearchCV's exhaustive search, RandomizedSearchCV samples a fixed number of hyperparameter combinations randomly, making it faster and more scalable. RandomizedSearchCV is particularly useful when dealing with a large number of hyperparameters, or when each evaluation is computationally expensive. It allows us to specify the number of iterations, controlling how many different combinations we want to try. Let's see how to set up RandomizedSearchCV with a support vector machine classifier. In this example, we defined a range of values for C, kernel, and gamma. RandomizedSearchCV randomly sampled 10 different combinations and evaluated them using 5-fold cross-validation. This method can be a game-changer when you need quick results without sacrificing accuracy. As we wrap up our discussion on hyperparameter tuning, it's clear how crucial this process is to refining and enhancing your machine learning models. By optimizing hyperparameters using GridSearchCV and RandomizedSearchCV, we can dramatically improve model performance and ensure robust outcomes. I encourage you to take these techniques and apply them to your own projects. Experimenting with different hyperparameter settings can unlock potential in your models that you might not have realized was there. Thank you for watching, and continue to challenge your analytical boundaries. I look forward to seeing you in our next video, where we'll dive even deeper into the fascinating world of machine learning, exploring new topics and techniques.
Stay tuned for more videos on Tech in 5.